Very good morning to all the students. I hope every one of you is in a good health. So today we're gonna start our next topic of the same chapter, that is chapter 3, atoms and molecule. In this chapter, in the previous lecture, we have done the law of chemical combinations, which were law of conservation of mass and law of constant proportion. So today we're gonna start our next topic, which is Dalton's atomic theory. So this Dalton is the name of a scientist and his full name is John Dalton, and he was born in 1766 in England. So John Dalton presented his atomic theory to explain the properties of matter, and his theory of matter became one of the most popular or foundation for the modern chemistry. So he also was the first one to calculate the masses of the atom. So in this atomic theory, he said a statement which was that all matter is made up of very tiny particles or indivisible particles called atom, and this theory was given in 1808. So that means that to justify this statement, he gave some postulates. So those postulates can be explained as assumptions, like he believed that if it is saying this, that means he believes some more things about atom. That's why it's called as atomic theory. So the first postulate is all the matter is made up of small particles called atom. So in the previous chapter we have read about matter. That means anything which occupies space and have mass is called as matter, and that matter is made up of tiny particles. So those tiny particles Dalton named as atom. So he said that any matter in this world or all the matter is made up of very small particles which are called as atom. And then he said that atoms cannot be divided. That means we cannot divide the atom. That's why the statement is all matter is made up of tiny particles, indivisible particles called atom. That means we cannot divide them further. Like atom is such a small particle that it is not divided. Okay, so was the theory of John Dalton. So next postulate was atom can neither be created nor be destroyed. So this holds true, as we have read about that the matter is not created or destroyed. That means law of conservation of mass, and that we have read this statement, so it was right. Then he said that atoms are of various kinds. They are as many kinds of atoms and element. He said that atom is not of only one kind, there are many kinds of atoms. That means we have different elements and every element has different atom. So it was also true. Then he said that atoms of different elements differ from masses and sizes and chemical properties. That means if there are different elements and their atoms will be different from each other, that means their masses will be different, their sizes will be different, and their chemical property will also be different. So no other atom of any other element is alike. So he said that it will always be different. The next postulate was chemical combination between two or more elements consists in the joining together of the atom of these elements to form molecules of compounds. It should be like that, to form molecules of compounds. Okay, that means in any chemical, if there is a chemical combination between two or more elements which are joining together, so they will form either a molecule or a compound. So when two atoms join, they form a molecule or a compound. So these were some postulates. There is one more postulate, that is the number and kind of atom in a given compound is fixed. It always in any compound there will be a fixed number of atoms. That means it is the law of definite proportion or law of constant proportion, because in that also we learn that in any to be any compound to be made, there should be a fixed number. So these were the postulates of John Dalton. But after he gave the theory, there were many speculation on this theory. Many scientists were looking forward to this theory, and it is known that some of the statement of this John Dalton's atomic theory were not exactly right. Okay, so there were some drawbacks. That means there were some drawbacks. That means they were not true and it became false because of the reason because his own statement does not fulfill the thing which he was saying. So what was the drawback? It was like, number one drawback was that it was that because he said that John Dalton theory of matter is that atoms were thought to be indivisible. He said that atoms are indivisible, we cannot divide them. But we know that under some special circumstances, atoms can be further divided into smaller particles, which are called as protons, electrons, and neutrons. So for this, we have to study the structure of atom. So first we will read about atom. So in the fourth chapter, we will be studying about the structure of atom, but here I would like you to tell in little brief section that atom is the smallest particle of an element that can take part in a chemical reaction. That means to carry a chemical reaction, the least we want that an atom. So it is the smallest particle of an element which take part in a chemical reaction. Now it's so small that the size is not measured in meters or centimeters. It is only measured in nanometer. What is nanometer? So nanometer is a very small unit. That means 1 nanometer equals to 1 upon 10 to the power 9 meter. So it means that it is like 1 nanometer equals to 1 nanometer, I'm writing it short, equals to 1 upon 10 to the power 9 meter. So this is so small. That means 1 nanometer, when it will be in the terms of this, 10 to the power minus 9 meter. So it's a very small unit. So how we calculate the size of an atom? The size of an atom is indicated by its radius. So radius means from the starting nucleus to the outermost shell. So it is called as the radius of the atom. So this is the radius of the atom. So this is measured. So this is the radius. So it is very small. So we have to calculate the size in nanometers. Okay, so this is very small, and the smallest atom is hydrogen. Hydrogen is the smallest atom. Alright, so now this is the structure of atom. So in the atom is a round sphere actually, and it's all empty. So only the heavy portion of an atom is here. There's a small particle inside the atom which is called as nucleus. Okay, so in the nucleus there resides proton and then neutrons, okay, so protons and neutrons are here in this small particle. That means atom is not a indivisible particle. Atom still has something else inside it. That means atoms have proton and neutron, and this is called as nucleus. So atom also have one more section. So what are these rounds? Now these are the orbits, and here resides the electron. Okay, so they are electrons, and we will be learning about the valence shell, valencies, number of electrons in the next chapter. So these electrons lives here in the orbit. Not live, actually they are found here, because living is a living term. We can't say live. So they are found here. Electrons. Electrons. And this is called as orbit. So this is the structure of atom. So since we are doing this drawbacks, so here under special circumstances atom can further be divided into protons, electrons, and neutrons. So next is atom of the same element can have slightly different mass. We'll again read the postulate. So here it's written that atoms of different elements differ in mass, sizes, and chemical properties. And one of the postulates was also that atoms of same element have same masses, but these do not hold true, because atoms of same elements can have slightly different masses because there are isotopes. So isotopes are the atoms of same element having different mass number but same atomic number. Like in the case of hydrogen, so hydrogen has 3 isotopes. It's H1, H2 and H3. So one is the atomic numbers because it's the hydrogen, so it will have a same atomic number, that is number of proton, but the mass number can change because now mass number is sum of protons plus neutron, and atomic number is number of protons. So proton will be same, that is why it's called as hydrogen, but here we can see that this is the number of neutrons because some hydrogen have one. This is the protium. Protium has 1 neutron and it has 0 neutron, and it has 1 neutron. It's called a deuterium, and the other one will have 2 neutrons. So because it will have only 0 neutron, so 1 is the number of protons, so 1, and then 1 plus 1 2, and 1 plus 2 3. So this is the isotope hydrogen. So it was said that atom of same element have same mass number, but here we can see that it's different mass number. That means it does not hold for true for hydrogen, and there are many more. There is chlorine also. Chlorine also has 2 different atomic masses. And then the other one was that atom of different elements have the same, they can not have same masses, but we can see that so there are some elements which have different atomic number but same mass number, like in the case of this argon and calcium. So let us do here, like this is the argon and calcium. So argon has atomic number 18, that means argon has 18 electron in outer motion, and calcium has 20 atomic number, but mass numbers are same, 40 and 40. So Dalton said that no 2 different elements can have same mass number, but here it's the same mass number, 40 and 40. So that means these were the drawbacks of John Dalton, because he said that atoms of same element always have same mass. So this was wrong. Atoms of same element can have different masses. And then he said atoms of different element has always different masses, but no, atoms of different element can have different masses. And then the third one was that atoms always, we cannot be divided into further. So they can be divided into further, that is proton, neutron, and electrons. There are many more drawbacks written in your book. You can see from your book, but these 3 are important, so please read these, and you can also read many other also. Now next I'm gonna solve the questions which I gave you for the homework. After this we will be doing question answers because the question answers which I gave you for homework, I had some answers in the homework, but many of you haven't submitted your homework, so I thought you are having some problem in the homework, so I will be telling you that. So let's do the solution number 1, answer. So the first question was you have to find out the like sodium carbonate was reacted with ethanoic acid, and then we got sodium acetate. Okay, so the values were like we'll write sodium carbonate was there, and it reacted with acetic acid, and it gave sodium acetate plus CO2 plus water. Okay, so this was a question. So now the values were that it was like sodium carbonate was 5.3, because it was like sodium carbonate reacts with acetic acid to form sodium acetate and CO2 and water. In this experiment, 5.3 grams of sodium carbonate reacts with 6 grams of acetic acid. So 5.3 grams of sodium carbonate reacts with 6 grams of acetic acid, and it produces 8.2 grams of sodium acetate, and then 2.2 grams of CO2 and 0.9 grams of water. Is that? It was like that. So what is that? According to law of conservation of mass, the right hand side will be equal to the left hand side. That means matter cannot be created nor be destroyed. So in any chemical reaction, the number of the elements or the matter should always be same. The number of reactants should always be same as in the number of products. Okay, so mass number should always be same. So these are the reactants here and these are the products here. Okay, these are the reactants and these are the products. So we'll calculate, like 5.3 plus 6, it is 11.3, and which is equal to this 8.2 plus 2.2 plus 0.9. So it will be 8.2, 2.2 and 0.9. So it will be, and yes, 3, and here, okay, then 11. So 11.3, that means the left hand side is equal to right hand side. It means the number of mass of the reactant is equal to the mass of the product. So this is true. That means this is the answer. Okay, so you can write G here. First question. Now second is calcium carbonate decomposes on heating to form calcium oxide and CO2. When 10 grams of calcium carbonate is decomposed completely, then 5.6 grams of calcium oxide is formed. So we have to calculate the mass of the CO2. We have not been given. So it is always that mass of product, or you can write reactant also, is equal to mass of reactants. Okay, so what is the mass of product? Product is calcium carbonate because it is decomposed. So calcium carbonate is decomposed. So we will get calcium oxide and calcium carbon dioxide. So these were the reactant, or these will be the that also. These before that these were the reactant, and then we got product as CaCO3, calcium carbonate. But here we are having calcium carbonate and we are decomposing it, like we are breaking it. So the product is calcium oxide and CO2. So number has been given. So mass of reactants means reactants is CaCO3. Okay, so that is 10 grams. Okay, and this we get CaO plus CO2. So M for mass and M for mass here. That means we get 5.6 calcium oxide, and we have to find CO2, mass of CO2. We don't know. So mass of CO2 will be this minus this, 10 minus 5.6. So we'll get 4.4 grams. That means it will be the mass of CO2. Okay, now the next question is hydrogen and oxygen combine in the ratio 1:8 by mass to form water. So we have to find out that how much oxygen would be required to react with 3 grams of hydrogen. Now it's very simple, since 1 gram of hydrogen, it requires 8 grams of O2. That means 3 grams of hydrogen will be required to burn 8 into 3, 24 grams. It's very easy. That means 24 grams of oxygen is required to react completely with 3 grams of hydrogen. So that is very simple. I hope you can do. So I'll be giving you more questions for your homework, and you have to write these postulates and the drawbacks in your fair notebook. Okay, so that is your today's homework. So you will be doing that. Till then, please study hard and take care. Thank you.